Question 1 is asking for the product of 84 times 76. Product means the answer to a multiplication problem. So the squares are set up for area model. If I expand my factors 80 plus 4 and 70 plus 6, I can meet these in the middle to make my multiplication problems. 70 times 80, 70 times 4, 80 times 6, and 6 times 4. Now I'm going to solve. 6 times 4 is 24. 70 times 4, cover up the zeros. 7 times 4 is 28. Put the 0 on the end, 280. 80 times 6. 8 times 6 is 48. Times 10, 480. 70 times 8. 7 times 8 is 56. I have 2 zeros here, so there's 2 zeros in my answer. Now I add all these squares up to get my final product. So I'm going to start with 5,600 plus 24. That's going to equal 5,624. Now I'm going to add my other square to that. I'm going to add 480. 4 plus 0 is 4. 8 plus 2 is 10. 6 plus 4 is 10. Plus 1 is 11. 5 plus 1 is 6. Not done yet. Now I have to add 280 to that. 280. 4 plus 0 is 4. 8 plus 0 is 8. 2 plus 1 is 3. 6 plus 0 is 6. My final product is 6,384. Now, let's show this if you did it traditionally. 84 times 76. You start in the ones place. 6 times 4 is 24. Keep your 4, carry your 2. 6 times 8 is 48, plus 2, 49, 50. Now we're done with the ones place and done with this. I can drop down and put a 0. 7 times 4 is 28. I keep my 8 and I carry my 2. 7 times 8 is 56, plus 2, 57, 58. Now add those up. 4 plus 0 is 4, 8 plus 0 is 8. 8 plus 5 is 13. 5 plus 1 is 6. 6,384. Same product. Next question is asking me to find the rule and fill in the empty boxes. So let's focus in on one box at a time. I put in 3, I get out 6. I put in 6, I get out 12. I put in 12, I get out 24. So I notice my numbers are increasing, which means I'm either going to add or multiply. So I'm trying to think of the pattern. Is there anything I can do to 3 to get to 6? Well, I could add 3. 6 plus 3 is 9, not 12. So add 3 doesn't work. So there's something else I can do to 3 to get to 6. I can multiply 2. 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. So I can put a number in this blank, any number I want. So I'm going to put 4. 4 times 2 is 8. So here I have a number that goes in, but not the number that goes out. So I have to follow the rule. 7 times 2 is 14. And 10 times 2 is 20. Now for my next box. I put in 10 and I get out 2. I put in 15 and I get 3. I put in 25 and I get 5. So my numbers are decreasing. So this is either subtraction or division. Well, if I subtract 8, 10 minus 8 is 2. So that's one way to get it. But if I do 15 minus 8, I do not get 3. So my rule is dividing. So how you could also figure this out is what could you do to 2 to get to 10? You can multiply by 5. So the opposite would be divide by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. 25 divided by 5 is 5. 35 divided by 5, think of the other part of that number. What times 5 equals 35? That's 7. Now, you have a 10 here, so I can go backwards. 10 times 5 is 50. 50 divided by 5 is 10. So there's your rules for your input-output. That's going to be a future topic we talk about, but it's a good review from 3rd grade as well. Next box, estimate, then label the points. So the first one, 56 times 37. 56 is closer to 60. 37 is closer to 40. Estimate, then multiply. 6 times 4 is 24. And I have 2 zeros here. 1, 2. 2,400. So that's going to go on my dots, maybe here. This is probably going to be 2,500. So we'll see. 43 times 66. 43 estimates to 40. 66 estimates to 70. Cover up my zeros. 4 times 7 is 28. 2 zeros, 1, 2. 2,800. That's going to be close over here to 3,000. Then see, 48 times 52. We estimate, then multiply. 48 estimates to 50. 52 estimates to 50. 5 times 5 is 25. 2 zeros, 1, 2. So that's going to be right about here. The question says, which estimate do you think is the closest to its actual product and why? So it's just asking you which of these numbers didn't have to move very much to get to its estimation. This one had to move 2, and this one had to move 2. So that's pretty close. This one had to move 4, and this one had to move 3. This one had to move 3, and this one had to move 4. So the ones with the smallest number is this 48 times 52, because they only moved 4 total numbers. Just trying to get you to think outside the box and explain your thinking. You put what you think. This is my thinking, so I want to see what your words are for that part. All right, the next one is asking us about properties. So number 1 says 5,342 times 6 times 0 equals 0. So if you have a lot of zeros, there's a property that has the word 0 in it as well. That's C, zero property multiplication. That just means anything times 0 equals 0. The next one shows me 738 times 12 times 43. 12 times 43 times 738. Well, it's the same numbers, but it's in a different order. So that is A, the commutative property. Number 3, 51 times 78 times 19 equals 51 times 78 times 19. Same numbers, same order, different grouping. That's the associative property. And number 4, 5,678 equals 5,678 times 1. This is showing you anything times 1 always equals its identity. It's the same on both sides. Anything times 1 keeps the same identity. That's B, the identity property. All right, let's look at our social studies question. Which region would be the best to visit if you wanted to buy fresh eggs from a poultry farm? Well, I'm thinking of where the poultry farmers live, and that's the region with parallel mountain chains. It even looks like letters in the word. It's Valley and Ridge. Number 2, if you drove north over the Potomac River, you would leave Virginia and be in what state? So I'm kind of thinking about my states here. Potomac River in Virginia. And this mustard with ketchup tastes nasty. If I drive north, I'm going to be in the state that starts with M. Number 3. What city could you visit to see military installations with large ships? So this is in the coastal plain region, and it's a very important city for military bases, especially the Navy. That big city is Norfolk. And number 4, what city could you visit to see the state capitol building? So this is pretty much asking you, what's the capital of Virginia? The capital of Virginia. That's Richmond. All right, guys, make sure you've shown your work.